Can you see this color in the back of the room? Okay. Yeah. Y varies directly as x for y is directly proportional to x Both of these statements represent what we call direct variation, and they can be expressed one of two ways. To say that y varies directly as x, or that y is directly proportional to x, means that y is equal to some constant times x. In other words, all that happens is that to obtain the y value, you must multiply the x value times a constant. Looks like a linear equation, doesn't it? Where this would be like the slope. But notice that direct variation, then, is a linear equation where the y-intercept is 0. You don't get to add anything to x. You just, any function where y is obtained by multiplying x by some constant is called a direct variation. We call this constant right here, k, is called the constant of proportionality. Proportionality. I'm sorry? It's a k. That's right. K is what we call a constant of proportionality. And for any problem of direct variation, k never changes. K is the same. So this is the most common way that you will see a direct variation problem. When you see one variable is equal to a constant times another variable, you have a direct variation. Another way that where this comes up again, a way that you can tell whether or not a set of values represent a direct variation, what would happen if I divide these two sides of the equation, both sides of the equation, by x? What would happen on this side if I divide by x? The x cancels, it'll just be k, and on the other side, y over x. So whenever you see this property that when you take a y value and you divide it by its corresponding x value, if you always get the same number, then you have a direct variation. Both of those equations are two forms of the same type of equation. Okay? There's a lot of examples of direct variation. For instance, as an example, I'd like you to consider this. If we let y be the total earnings of a person, and x represent the number of hours worked, right? We would say that y varies directly as x. That is to say, the more hours you work, what happens to your total earnings? They go up, but if you work fewer hours, your earnings stay the same. So for example, right, suppose that I tell you this. So with this example right here, suppose that I tell you that.
So K could represent like the $8 per hour?
Very nice. So you beat me to the punch. What would K be in this constant? In this, what does K represent? Right, Benny says, well, in this context, K would represent your hourly wage. Exactly right. That's a good insight, and that's what we're going here. Suppose that I told you this. Y is 54 when x equals 6. The first thing you need to be able to do with one of these things is find k, and b, find y when x equals 8, and c, what value of x yields a y value of 80. So these are the three questions that I could ask in a direct variation problem. First, I apologize here. I forgot the one statement. I apologize, I meant to write this. So suppose that I tell you that y is the total earnings and x is the number of hours worked, then we can say y varies directly as x. Now, your job, whenever you have any of these problems with direct variation, is to first translate the sentence into an equation. So here you go. What's the form? How do we write y varies directly as x? Y equals kx. All right. Typically in a problem like this, you are going to be given one pair of values, x and y, that you can plug in, and then you will be able to solve for k. Let's do that here. To find k, we're going to use y equals 54 when x equals 6. What am I going to plug in here?
54.
And here?
6.
6. So here's the equation that we get to find k. 54 is equal to k times 6, which we would write as 6k. Does that make sense? When this person worked 6 hours, he made $54. How do I solve for k? I divide by 6. And 54 divided by 6? 9. Okay, so now that you found k, right, you can plug it into the equation, and now you know that for this problem, this equation is always true. Y is going to equal 9 times x. And what Manny said a little while ago is absolutely right. What does that 9 represent? Look at the units right here. This is $54 divided by 6 hours. So the units here would be dollars per hour. So when we say 9, we mean $9 per hour. That's the hourly wage for the person. So now we can answer this question. Find y when x equals 8. Well, here's my equation now that I can use. So y is equal to 9x. What is the value of x in question here?
8.
8. This is another way of me asking, how much is this person going to make when he works 8 hours?
72.
And you get 72. What are the units?
Dollars.
Per hour.
Dollars. $72. That's right. Now, what if this person wanted to make $81? How many hours does he have to work? Well, y equals 9x. Where do I plug in this 81? For which variable? The y value is 81, right? So this 81 goes here. And
Wait, why does y equal 9x?
say that one more time.
Why does y equal 9x?
Y?
Yes.
Because we were told that y varies directly as x, we had this equation, y equals kx. Then we solved for k in part A, and k turned out to be 9. Then this equation represents this problem every time. For this problem, that never changes. The equation stays y equals 9x, meaning in all of this example here, we're talking about a person who makes $9 an hour. That's all. So here, you can solve for x by doing what to both sides of the equation?
Divide by 9.
Divide by 9. And x equals what?
9
9 what?
hours.
$9 hours. Not $9. These are 9 hours.